All right, everybody, welcome on in. So, fixed some technology. What's the term? Technical difficulties, right? Was having some problems with Zoom last week. Zoom did an update, and then they change a bunch of your settings, like a lot of programs do. And then I had to hunt around and find the right one. So it looks like Zoom's working. As far as I can tell, everything's back to normal with Zoom. So we're going to continue our discussion today. Last time we were looking at polynomials, introducing polynomials as far as what's the vocab. Let's see, that's the right one, right? Yeah, right. So introducing polynomials, the vocabulary of polynomials. We talked about the degree of the terms in a polynomial. We talked about the degree of the polynomial. We talked about writing things in standard form. Adding and subtracting them is pretty straightforward. It's essentially just combining like terms, right? So two terms that have the exact same type of variable can be added or subtracted. If they don't, then they can't. So in other words, if you have one term that has an x squared, one term that has an x cubed, those can't be added together, right? And then we went through and looked at that. So the next step is the polynomial multiplication. Most people get a hold of polynomial multiplication pretty quickly, and they kind of make sense of it, and then it's fine. And then what you're going to see is, oops, I'll move this over so you can see it. After polynomial multiplication, then we get into factoring. And I'm not going to rush us through factoring because it's one of the most important topics in the class. I want to make sure everyone does it, like that everyone's, good at it, right? It's one of those topics where when you get to college algebra, if you can't factor, it's going to be difficult, right? You're going to have a hard time. So we'll take a nice, reasonable pace through factoring to make sure people are getting it and that you can do it. So, but first we're going to look at multiplying polynomials. Now, here's what I'm going to say is I'm going to teach you the most general way to multiply polynomials. But every single time that I teach this, well, I shouldn't say every single time. Most of the time when I teach this, a student will come up to me afterwards and say, my teacher told me a totally different way of multiplying polynomials. I get this in factoring too, but I especially get it with multiplication of polynomials. And they say, my teacher taught me to do it totally different. So what happens is there's a lot of steps that can happen in your polynomial multiplication. It's very easy for your polynomial multiplication to have 6, 9, 12 steps that you're doing in the meantime. At the end of the day, all these different versions that you've learned and that you can see on YouTube, if you go there and you've had, maybe a teacher in the past showed you something, there's all these different versions that are just organizing the work differently. They look different when you look at them, right? I've seen people show me the box method, and there's one called like the Chinese method because I guess it came out of China, or there's all these different versions. But you can sit there and you can point and go, yep, this is the same thing as this. It's just written in a box form. This is the same thing as this, but you're writing like in a diagonal form. And you're like doing this. It's all really about organization. So just keep that in mind because I think sometimes students they go, oh, well, I like the way my teacher did it, which is fine. As long as you're doing proper multiplication, I don't care how you organize your work. But that's really the difference between all these methods is, are you organizing it in a rectangle? Are you organizing it in a row, in a column? They all come down to the same thing. In fact, I've done this before. I'm not going to do it right now, but you can do this in class where I'll write it the way I do it, and then like a student does it the way they're talking about, and they're saying, oh, well, there's this other method I learned that's totally different. And once the two methods are written side by side, you can literally like point to them and go, see this term, see how it ends up here? See this term, see how it's over here? And you can find all the same pieces that are in both ways of doing it. It's the same exact work. It's just how you're organizing it. So don't get hung up on like that there's these different ways to do it. There's really not. There's like how you're organizing your work on the paper. Okay? So that's really all it comes down to. So whichever method you like, that's totally fine. You don't have to convince me that or sometimes people want permission. Can I still use this certain method that my teacher taught me in school? And then I'll say, well, can you show me? and they do, and I go, yep, that's the same thing. You're just writing it a little bit differently than I am, but it's actually the same math that's going on behind the scenes. So totally fine. Whichever method you're comfortable, that's the one that you should use. Okay, as long as it's a legit method, right? So here's the thing. Polynomial multiplication breaks up into a bunch of little pieces, all of which are monomial times monomial. So remember what a monomial is? Oops, I can move this over now, I guess. A monomial is a one-term polynomial. And you go, but wait, I saw some problems on the homework that was a binomial times a trinomial. Right. So if you have a binomial times a trinomial, that breaks down into 6 steps of monomial times monomial. Right? So everything always boils down to you were going to do a bunch of little monomial times monomial multiplications. And then how you organize those, like those 6 steps, how you organize those 6 steps, that's how you end up with the row method or the box method or the Chinese method. Like all these different versions, it's just how you're organizing those 6 steps. But anytime you multiply a binomial times a trinomial, it's going to be 6 monomial times monomial multiplications. So let's start off with monomial times monomial, since that's really, each of these problems is just going to be doing that a whole bunch of times. And students are good with this. All right, students pick this up almost immediately. So let's say I have 2 monomials. Let's take 3x to the 5th times, and I'll just put the dot here just since we're kind of focusing on that, times 5x to the 7th. I think we kind of maybe even looked at this a little bit last time, but we'll go over it since we're setting the stage here. Okay, so I want to multiply these together. Oh, maybe I'm thinking of the scientific notation, so maybe we didn't. Either way, I want to multiply these together. So what do I have? Well, I have 2 numbers I can multiply. Okay, 3 times 5 is 15. And do we remember we've got those exponent rules? X to the 5th times x to the 7th. Right? This is where that's important. Am I supposed to add or multiply those exponents? Which am I supposed to do? Hopefully you remember that's when we're supposed to add those exponents, meaning this becomes 15x to the 12th. So see how we just did a monomial times a monomial, giving us a monomial. That's in these problems, you're going to organize your work, and then you're going to do a bunch of these kinds of multiplications. But that's good because people pick these up pretty quickly. Okay, so let's do another one. Okay, I'm going to give you a minute to try to do this, right? This will be a good test to see how well you're understanding what's going on. Try to figure out, some of you can do it in your head, some of you can just write it down, whatever works. I'm going to give you a little bit, so 30 seconds or something, to try to figure out what you think this answer would be. So see if you can get it before I do, right? You don't have to put it in chat or anything, but just see if you can figure out what this answer would be. And if you get it right, then that's a good sign, right? Okay, so 2 times 7 is 14. Then we're going to have x being raised to a power. If I add 8 and 13, I get 21, giving us 14x to the 21st power. Okay, is what that should be. So if that's what you got, great. If you made a mistake, and then maybe it occurred to you what you did, and now you get it. Otherwise, you'll, like I say, students pick this up pretty quickly, the multiplication piece. So you're multiplying the coefficients, you're adding the exponents, right? And there we go. And you get that piece, okay? So monomial multiplication, students get it pretty quickly. Okay, so what about once we start getting more complicated? What if I have 3x squared times the quantity? Oh, actually, before we do that problem, let me... Oh, yeah, I did want to do this. So let's do 2x squared plus 7 Okay, so let me actually define our polynomial multiplication, because usually what probably happened if you've seen a different method in the past was your teacher defined polynomial multiplication as the way they showed you to do it. But what I'm saying is there's lots of ways to do it, all of which fit this definition of polynomial multiplication. It's just a matter of organization, right? It's like a closet. People have different ways they organize their closets. They're all legitimate, right? Let's see. So polynomial multiplication. To multiply polynomials to multiply polynomials, we multiply every term in one polynomial with every term in the other polynomial. And I'm going to have to do, let's see. There we go. To multiply polynomials, multiply every term in one polynomial with every term in the other polynomial. This is actually the definition of polynomial multiplication. Every single way that you have all learned, or maybe this is the first time you've ever seen this, but for those of you who have learned this at some other point along the way, whatever way you were shown, it fits this definition. Every term in one polynomial was getting multiplied by every term in the other polynomial. And that's what the box method does, is it matches up the terms like vertically of one polynomial, horizontally on the other. And as you fill in the box, what you're doing is multiplying every term on the vertical polynomial with every term on the horizontal polynomial. When we do it in row form, we're essentially just doing the distributive property, which meets this definition. Right, so you can sit down and you can analyze these different ways and see they all match this, which is why you can match it up. But you can literally do it two different ways and match the terms up and go, oh yeah, it's showing up here and it's showing up here. Oh, in this problem it shows up here. Over here it shows up here, and it's the same exact stuff, right? So okay, so back to our problem, because that's the definition I'm going to keep falling back on, because then you can, like I say, you can organize it however you want. What do I have here? I have a monomial and a trinomial. Well, if I want to multiply the monomial times a trinomial, that means I take every term in the monomial, which is only 1, and I multiply it by every term in the trinomial, which is 3. So I'm going to have 3 multiplications that I'm doing here, right? We've seen this as the distributive property before. This is just the distributive property for polynomials. So now I have 3 of these, right? I said it all boils down to these monomial times monomial multiplications, like up here. I've got 3 of those to do right here. Okay, so let's see. I think I have enough room. Let's be brave and try to do it. Okay, so 3x squared times 2x squared would give me 6x to the 4th. If I make a mistake, tell me. I'm trying to do math and teach and stream at the same time. So if I mess something up, let me know in chat politely. It's my equal sign. There we go. So we get 6x to the 4th. Okay, then we're going to get plus 21 plus 21x x to the 21x to the what, 3rd. I might go, wait a minute, why is it 3? Because remember, an x squared times an x, this is really x to the 1. So x squared times x is x cubed, right? 3 times 7 is 21. X squared times x is x cubed. 3x squared times 1, well, that's easy. That's just going to be plus 3x squared. And there we have our new polynomial, right? So notice it was 3 monomial times monomial multiplications, and then we have our answer. And there's no more There's no more terms that can be combined. This is fully simplified. We're ready to go. We finished the problem. We're done, right? So the thing that gets harder about polynomial multiplication is the organization. Which is what I've been referencing, right? Once the number of multiplications you have to do in a problem grows to 6 to 9, how do you know you're getting them all? How do you know that you're getting every term in one polynomial and multiplying it by every term in the other polynomial? And that's where these techniques come in that your teachers may have shown you in the past. FOIL, box method, all this kind of stuff is specifically to make sure that you get every multiplication and that you don't duplicate a multiplication, right? Both of those will mess you up. So let's go to one that many of you have seen before, is one that is taught a lot, and it's called FOIL. Now, here's what I'm going to say about FOIL. People use the word FOIL incorrectly all the time. And it's just, you want to try to use this word correctly, because when you're talking about math, if you're asking your teacher something and you're using the wrong language, it's not that we're trying to be a pain and be like, oh, you didn't use the right language, so I'm not going to answer you. It's literally just confusing. We don't know what you mean if you're saying the wrong thing at the wrong time, right? It just makes sense. If you were to say addition when you meant multiplication, I'd be very confused and go, wait, what? Why are you trying to do that then? It's the same thing with FOIL. I'll hear students use FOIL. Basically, students use FOIL for everything, when actually it's just a very small case where FOIL makes sense. So FOIL stands for first, outer, inner, last. It is telling you the order to do 4 multiplications for a very specific problem. Okay, so first, outer, inner, last. We can write it first, outer. Is outer have 2 T's or 1? That looks like otter. I don't. Outer, inner, last. Right? It's literally just telling you to do your 4 multiplications. But for what type of problem? It's specifically for a binomial times a binomial. Let's make this a 7. Right? Because if you think about it, if we have a binomial times a binomial, and this is probably the most common polynomial multiplication that you're going to do in these math classes, is a binomial times a binomial. Okay? There are 4 terms, 2 in the first polynomial, 2 in the second. So if you think about it, if I multiply every term in the first polynomial by every term in the second polynomial, that's 4 multiplications that I should be doing. Right? First, outer, inner, last. 4 multiplications. So FOIL is fine. One of the problems is people will use FOIL to just mean any kind of polynomial multiplication. But FOIL only works in the case of binomial times binomial. So a student will come up and say they're doing a binomial times a trinomial, and they'll say, oh, well, I'm foiling it to mean multiplication. And usually as a teacher, we kind of figure out what they mean and go, you're using the word wrong, but I get what you're saying. You're just trying to say you multiplied them. The big problem is later on, students will use FOIL when they're factoring, and that is confusing. When a student comes to you and says, I'm trying to FOIL this, which is multiplication, but what they're really trying to do is the opposite of multiplication, that can lead to confusion. So just try to understand what FOIL actually is, and just try to use that vocabulary at the right time. It definitely helps us communicate when I'm trying to help you out with that. Okay. Sorry. When these things update, there's all these like new symbols and everything, and I'm trying to figure out what this is on my Zoom, but it looks like it's just that must mean I have a live meeting now. It's weird. Okay. So I'm going to go through and do FOIL on this. First means the first terms in each polynomial. 2x times 3x equals 6x squared, right? Okay, 6x squared. Now I do the outer. That's the outer terms. 2x times negative 5 is negative 10x. Okay. Negative 10x. Now my inner, so that's the inner parts here. 7 times 3x is plus 21x. And then my last, that's the last terms in each one, that's going to be minus 35. Now, we're not done because notice that the two terms in the middle are like terms. So students will go, should I combine those? You kind of know deep down, right? You're just asking if you can get away with not doing it. Yeah, you combine the like terms, right? So we want to combine those. So 6x squared. Okay, negative 10x plus 21x will give us 11x. Oops, that should be plus 11x and then minus 35. So see how I combine those middle terms? Now it's fully simplified. It's written in standard form, right? Just get in the practice of writing things in standard form right now. I see some students, they're like, what's the big deal about writing it in standard form? And then they make tons of mistakes. So just get into the habit of writing it in standard form. This polynomial stuff, a huge part of it is just being organized. Organizing your work in the proper way so that you'll minimize mistakes and then you'll be fine. Okay? So that's all there is to FOIL. You're doing your first, your outer, your inner, your last. That's all that means. Okay? So that's pretty straightforward. Students usually do pretty good with that. Here's one thing I'll tell you that definitely confuses students. Not every student, but a lot of students get confused by this, is when they see something like this. Say 5x minus 3. Okay, so here's an important topic because this is a mistake that people start making in algebra, and we fix this mistake, and then they make it again in college algebra, and then we fix it, and then they make it again in calculus, and we fix it. So you just kind of want to learn this now so you don't make this mistake right here. A lot of times, like literally in my calculus class, and those people have seen it for years before they get to there. In calculus, you'll see students do this. What I'm about to do is wrong. Okay, by the way, so I want to make sure everyone understands the wrong way to do it. Is they'll go, oh, well, okay, well, I've got 5x minus 3 squared, so isn't that just 5x squared minus 3 squared? And then they go, okay, so isn't that 25x squared minus 9? Because I squared both of those terms there. The answer is no. That is not correct, right? Basically, what you're saying when you do that is that we actually do a whole exercise on this one when we're on ground. AB squared equals A squared minus B squared. This is incorrect. This is wrong. All right, so once again, I want to make sure everyone understands. Wrong. This isn't true. A minus B squared is not equal to A squared minus B squared. Take any numbers you want. Take any positive numbers you want and stick them in here. 5 and 7 and 4 and 3. Put any numbers you want in there. A minus B squared does not equal A squared minus B squared. But you will regularly see students do this where they just take each term and square it. Do not do that. Okay? So, all right, well then if 5x minus 3 squared is not equal to 5x squared minus 3 squared, then how am I supposed to do it? Okay, so the right way to do it is to recognize that 5x minus 3 squared is equal to 5x minus 3 times 5x minus 3. And as soon as I show students this, they go, okay, I know what to do. Now I'll just FOIL those out. Right. That's what you're supposed to do. So, but there's something about this when students see this, their sort of multiplication thinking just freezes up. It just stops. And I've seen students just stumped. I have no idea how to do this problem because they know this one's wrong sometimes. Like the students will go, I know it's not this, but I have no idea what to do. And then as soon as you tell them, just write it out as the multiplication, boom, they're done in like 20 seconds. Okay? So, so whenever you see this thing where it's to a power, just expand it out and your brain's going to go, I recognize that. I recognize how to do that multiplication. And then you're going to be just fine. Oh, and and there's a question I'll get to in just a second. But let me finish this out so that you can see what happens. If I do this multiplication, I get 25x squared. I get minus 15x. I get another minus 15x. And then I get a plus 9. Oh, why isn't it recompiling? There we go. So if you look at this, this whole thing should now simplify down to 25x squared minus 30x plus 9. Notice how the wrong way of doing it and the right way of doing it have some similarities. You know, there's a 25x squared in both. There's a 9 sort of that appears in both. But this middle term is the big difference, the negative 30x. That is really what keeps this method up here from being correct. So make sure you write it out as a multiplication, and then your brain's going to remember what to do. Okay. Oh, let's see, there's a question. Do you use FOIL because it keeps your terms in the correct order and standard form when you combine? So the truth is, yeah, FOIL is beneficial in that it usually, if your terms start in standard form, they're usually going to end in standard form. But let's see, is that always correct? Probably. But FOIL is just it's like a super popular way that is caught on, and most students have seen FOIL, so we just keep teaching it. But if you want to think of it as the distributive property, you're welcome to do that, right? It's really just some tool of organization to get all those multiplications occurring, right? And it happens to be a word. People can remember the word FOIL because it's kind of like a word like aluminum foil or something like that. But you could even do it in the other order and it would still work, right? But I don't think it would be as popular if we called it oilf, where we did like the F last. It would still be correct, and then you would just reorder your terms, but it just hasn't caught on because it doesn't have a, like a fancy word to it. So there's nothing that makes FOIL like the right way to do it. It's just a real convenient way that students seem to get. So to your question, Anne, about like why we do it that way, there's not really an answer. If you want to think of it as distributive property, or if you want to do it the box method, it's totally fine. Totally 100% mathematically correct to use either the box method or FOIL, whichever way is comfortable for you. Totally fine. Okay. All right. So let's move ahead and let's see, where are we with the polynomial? I wonder what are they going to get to? Okay, we'll do those. I'm trying to remember which problems. And here, trinomial times trinomial. Okay, so let's take a look at those. This looks scary, right? Oh my gosh, look at that thing. That's a trinomial times a trinomial. That's about as bad as they're going to get in this class. And it's actually, it's not super short, but it's not terribly hard. You're going to have 9 multiplications to do here, right? Because you have a 3-term polynomial. Each term here gets multiplied by each term here. That's 9 multiplications that you're going to do. And usually the way that people like to organize these is just by using, you go through, pick a term from your first polynomial, multiply it by everything in the second one, then go on. So let me see about copying this. Let's go to a new page. I don't need it to be large. Let's go. Negative x squared minus 2x minus 2. Negative x squared minus 2x minus 2. And negative 2x squared plus 7x plus 1. Negative 2x squared plus 7x plus 1. Did I get that right? Okay, that looks right. And where's our problem? Here it is. Okay. So how do I want to multiply these? Like I said, you can find, you go on YouTube or just look online. There's so many methods. There's the vertical method. There's the horizontal method, which is often taught in books. The reason it's taught in books is because we're used to writing things across on a single line and reading that way. So that's why, right? And it takes up less room in the book, so that saves on printing costs. The vertical method is totally fine to do. The box method here would work great. Now, FOIL, we don't want to FOIL here, right? Here's where that language starts to get confusing. We wouldn't use FOIL because FOIL only has 4 multiplications in it. This one needs 9. So FOIL doesn't make sense. So try not to say you're foiling this. Try to say you're multiplying this. Okay, just I'll understand you a little sooner if you say that. So what I'm going to do, I'm first going to go through and multiply everything by the negative x squared. So, and I'll see if I don't know if I'm going to be able to get the spacing right on here. In fact, yeah. Okay, let me try this. So I'm going to multiply everything in the second polynomial by this negative x squared. So that's going to give me 3x to the 4th. So 3x to the 4th. Now I multiply the negative x squared times the 7x. That gives me negative 7x cubed. And then the negative x squared times the 1 just gives me negative x squared. Let's see, did I get that right? Let's see. So 3x to the 4th minus 7x cubed minus x squared. Okay, good. Now what I do, I come back and I grab this second term. And I'm going to multiply everything in the second polynomial by this term. So now it's like I'm distributing the negative 2x into here. So let me do that on the second line. So that's going to be, let's see, that's going to be 6x cubed minus 14x squared minus 2x okay. Now I'm going to go through and multiply everything by the negative 2. So everything in the second polynomial will get multiplied by the negative 2. And that'll just be what? 6x squared minus 14x minus 2. Now, I've forgotten give me a second. I've forgotten what the command is to give space here. So let's see. Space beginning of line. Let me see if I can find this command. See if I can get this to line up right. So what you want to notice, see how I've done 9 multiplications here, right? The 3 terms here multiplied by the 3 terms here, that was 9 multiplications. And I should be able to get this to come out. If I can get the spacing right. There we go. Okay, perfect. All right, great. And then let's do this. If you shift where you write those things, instead of writing them in perfect columns, if you shift them, you can line them up and it becomes even easier. So here's how I prefer to do it. And let's make this a 10. See if that might have to shift things a little more. Let's go 11. Okay. So see how this is the same 9 multiplications that I just did, but do you see how I organize them? I organize them in columns according to like terms. So as I'm writing these out, like if I'm doing this on a scratch piece of paper, this is generally how I organize it. At first I had it written because I didn't know what the spacing was going to look like. But here, so when I go through and do the first one, I've got 3x to the 4th minus 7x cubed minus x squared, okay? But then when I take the next round, which is to take the middle term here and multiply it here, I get a cube. And we go, oh, I already have a cube. So I put it in this column where the cubes are. So see how the columns are like terms? That makes it way easier at the end to just go add them up, because you're just kind of adding up by going down. And you go, okay, well, this will be 3x to the 4th minus x cubed. Let's see if we have minus 15 plus 6 would be minus 9x squared. And then minus 16x minus 2. See how the columns are kind of lining this up for us? I actually find, for me, that's the cleanest way to do it. And I find a lot of students like that. It's like how you see it in a book, except in a book, they just write these all on a row. And when you have those 9 terms in a row, I don't know, your brain kind of gets overwhelmed, scrambled a little bit trying to match up the terms. But if you can write them in these columns like this, it's real easy to just add them all together at the end and get that final answer. All right, so that's just how you would do this one. So really, this is the method that you can use sort of for any polynomial times any polynomial. Is you just, each time you write it, take a term here and multiply it into this polynomial, it gets its own little row. And then when you continue from there, you just make sure you're putting things in the right column that have the right like terms. I find this actually even slightly better than that box method, right? I definitely see the merits of the box method, but to me, this kind of lines them all up really nice where you got your like terms all in a row. But again, whatever method you like for your organization, the one that works for you is the one you should use. I'm not going to judge anybody's method and say, well, my teacher taught me this, because we've seen believe me, I've seen dozens and dozens and dozens of ways. Some are really great, some are super bizarre and have like weird stories with them and stuff, but if it works, if it helps you remember it, that's totally fine. So that's how you would do that one. Okay. And then we get into something like this, which this is another one of those cases that really throws students until they see it and like it's explained to them and they go, oh, that's all I had to do? Yeah, so what we're doing here is we're multiplying polynomials, but now you're being asked to multiply 3 polynomials. And this happens all the time in mathematics, where we define a term based on 2 things, and then people get to a problem that involves 3 things, and they go, well, wait, what am I supposed to do? This is 3 things, and the thing you showed us was two things. Well, what would you do if I gave you 3 numbers and told you to multiply them together? You probably would take the first 2 numbers and multiply them, and then you would multiply by the 3rd number, right? There's no special technique for multiplying 3 polynomials. It's that you multiply 2 polynomials together, and then you multiply that by the 3rd polynomial. So when you're trying to do this problem here, in fact, let's see the solution. Yeah, that's fine. What do they do? Well, you've got your 3 polynomials. Well, they multiplied these 2 together first. See how the x minus 2 didn't change, but this part now has these multiplied together? Now you're going to multiply these 2 together. And this is that box method I've been talking about, right? So those of you who like that, it forms a box. So it's perfectly fine. It's a good method to go through and use. You get your thing, and then you organize them, right? So there's nothing weird or strange about multiplying 3 polynomials together. It's just multiplying two polynomials together and then multiplying two polynomials together again. And you'll get that, okay? That's all there is to that one. Let's see. I can just sort of start to introduce factoring, and then we'll officially get into factoring next time. So I'll sort of set the stage so that you start to know what's going on with factoring, and then we'll deal with it later. This process that we've been talking about today is called polynomial multiplication. It is very easy to program. Most students are fine with it. You're just basically following an algorithm, right? It says multiply these two terms together. Now multiply these two terms together. Now multiply these two terms together. And you do that till you have all your terms, and then you just do a little cleanup work at the end, right? So from a theoretical standpoint, polynomial multiplication, once you've seen how to do it, once you've done a few of these, not terribly complicated, right? You can literally program a computer to do it relatively easily. So that's the process we've been working on. You start with something like this, you do polynomial multiplication, you end up with something like this. Well, notice what's happened every single time that we've done a polynomial multiplication problem. We started off with polynomials being multiplied together. That is, we had a product. Here's a polynomial, and it's the multiplication of the two. And that might seem obvious because we've been doing polynomial multiplications. But just, you want to notice the form of our answers. It's a polynomial times a polynomial. But what do we end up with? What we end up with is a series of plus and minuses, right? Up here, we have a product. Notice down here at the end, there's no product. There's a term minus another term minus another term minus another term minus another term. There's no multiplications because we did the multiplication. Well, depending on what you're doing in mathematics, there is times where you want your problem to be written like this, where there is no products at all. But in fact, most of the time, we want things written like this as a product. And you might go, why? Why would we want to do that, right? It just kind of seems natural, especially since you just learned how to multiply polynomials and put them in standard form, where you'd go, well, this seems like the better form. And sometimes it is. But there are certain operations that we want to do that we can't, like we basically lose our toolbox if we don't have a product. So if we can't apply a multiplication in there, we lose a bunch of our tools that we want to use. Kind of like back with when we were doing linear equations, and I talked about how, or maybe if you took me for Math 1, with linear equations, a lot of times people will take the tools of linear equations and they will try to apply them to linear expressions. But you can't do that because once you lose the equal sign, you lose those tools that say, add the same thing to both sides of the equal sign, right? How can you add the same thing to both sides of the equal sign if there's no equal sign? You lose that as a tool. Well, we have tools we're going to be learning in the next couple weeks that we can apply to this top row that cannot be applied to the bottom row. And that's a problem. So next week, we will be looking to basically doing these problems backwards, right? We were looking at taking this and multiplying it out to get this. Factoring would be taking this polynomial down here and figuring out how to work backwards and write it as this thing up here. Okay, so basically turning into something that sums and differences and writing it as a product, because then we have those additional tools in our toolbox which we can bring out and use. Now, I will tell you, factoring is more complicated, right? It's complicated from like a student perspective, where I think almost 100% of students would agree that factoring is more difficult than polynomial multiplication. But even from a theoretical standpoint, in a few minutes, if you know programming, in a few minutes you can write a program to multiply polynomials. Factoring, that's really, really hard. That's what keeps your browsing safe on the internet, right? Is actually the fact that factoring is so much harder than multiplication is. I'm oversimplifying here, but basically when you send your credit card information to Amazon, Amazon has a really big number that they're storing on their end. Your browser has a really big number it's storing on your end, and they multiply those to get a really huge number that's like a key. It's sort of like a key. Now, if you're on either end, if you're Amazon or your browser, and you know one of multiplied numbers to make that product, it's really easy to undo it and divide. But if you're someone in the middle who's trying to like hack in the middle and figure that out, it's really hard to factor that big number, right? Again, I'm way oversimplifying, but this mathematical concept is part of what makes it so that you can be safe on the internet when you put your credit card in a website and know that someone in the middle is not going to steal it. Is this stuff actually taking place? So, but we won't get into any of that. Just sort of giving you a heads up that factoring actually does affect your everyday life every time you do something secure on the internet. So we will be doing that next week. So those of you who want to work ahead and get into factoring, go ahead. It wouldn't be a bad idea to try to work through some of that so that when I'm talking about it in class, it's going to make that much more sense to you, because factoring some students pick it up easily. Some students struggle with it a little bit. It is one of the most important topics in this class, right? Your teachers in pre-calc, when, some of them, like I say, if they're trying to figure out if maybe you need to go back to intermediate algebra or something like that, a lot of them are going to judge you on your factoring. If you can factor well, you're probably going to make it through pre-calc or college algebra or trig. If you can't, you're really, really going to struggle in those classes. So it depends what you're taking. You don't really need factoring for statistics or those classes, but it's one of the more important topics. Oh, what day is today? Sorry. Yep. Forgetting what day it is. Yes, it's only Monday. Wednesday. When I see you on Wednesday, we'll continue with that. Yeah, thanks, Ann. So try to stay caught up. Feel free to work ahead. Remember, at the end of this chapter, once we work through all the factoring, that's when the test will occur. Sometime probably right after the middle of the month, you'll have your test. So you should be working on getting yourself caught up. If you're behind, looks like most students are doing great with the homework. So keep that up, but come to me with questions. If you haven't looked at something for like 4 weeks, just go back and spend 5 minutes looking at it. It'll be that much easier for you when you're getting ready for the test. Okay? So I'm going to shut down the YouTube stream. Anyone who wants to jump into Zoom is welcome to. And then I'm going to campus, and I have my on-campus office hours. Anyone who wants to see me there, come see me there. Okay, thanks, everybody.